So we covered SDLC part, starting with when people are doing coding, what can we build? And then once a PR is raised, right, what kind of products can we build? And once code goes to production, and let's say there is an issue with the product or there is an issue with the code, right? How faster can we identify it? So we took these three challenges and we built products on top of it.
How does this compare against what Sachin was mentioning in one of the earlier videos, wherein you create a memory bank and the client uses memory bank and it has got more context and then it can take specific commands?
The only missing piece in that was ChatGPT or any LLM at that point, right? Why? Because extracting something from document, which is little unstructured, was not very straightforward. But that's where LLMs really helped us to finish that whole pipeline. Why LLM makes a decision of what it makes, right? Nobody knows. Yesterday, Anthropic released a simple tool to show how it works and all, but it is still not to the extent that you actually understand why it's answering what it's answering, right?
Hey, I'm Chirag and this is Arvind.
Hi.
So Arvind is known as AG, fondly called as AG here. He's someone with whom I can not only talk about tech but also debate about philosophy. Today we will keep it narrow to AI. So Arvind, tell me, how did your AI journey start?
It all started in 2023 when ChatGPT 4 was launched, 23. The first time when we looked at it, right, it just felt like it is definitely something. It's not like that old traditional model, AlphaGo kind of a thing, which will be only specialized on one particular thing and it can only do that, right? We realized that it will be much bigger and it's going to go in that direction. So it will become 100x, 1000x kind of a direction, and we want to do early betting.
But what is AlphaGo, right? I mean,
yeah, it's a reinforcement learning model, and it was done by DeepMind, and they made this model play with the current champion in 2016, and out of 7 games, I think it won 6 games. And in one of the game, it actually played a move that nobody expected. That's when everybody thought like the model is actually thinking, but it's more of a tree expansion than a thinking. But yeah, it felt like it's thinking, and it just made a move that stunned the whole world.
Is it the one who had defeated a human in chess?
Yes, this is Go game. It's a different game. It is much more complex than chess, because I'm not trying to compare, but it's just that Go has more possibilities to evaluate than chess because of number of squares on the board, right? And but the only problem with that kind of direction is it is not generalized. So how humans grow is like, okay, once you learn something, you could use that knowledge to learn something completely different, right? Whereas pre-LLMs, it was mostly like you have one particular model which is specialized on something and it can only do that. You can't use that knowledge or use that as a base to just jump onto something completely different, right? Hence, one of the main reasons why pre-LLMs or pre-ChatGPT launch, it was not that big of a hype. But when ChatGPT launched it, right, it felt like it is very general, and it felt like you can do anything. Right, and you can augment it in different ways. You can do fine-tuning, RAG, just a new set of easy generalization tasks. And then we started asking questions like, how does it really work, right? So our first intriguing thing was just go inside, understand how it works, get the sense of it. In Juspay, we always talk about first principles, understanding things from fundamentals, right? Because if you have solid basics, rest all would just look like a mapping rather than, oh, everything is a new stuff, right? So hence what we started doing is we went back to the basics of ML. We understand how does a linear regression works. We understand what is a differentiation. We understand neural networks. We understand backpropagation. We understand chain rules. Then we understand CNNs, RNNs, LSTMs. If you just want to draw a line of how LLMs came in, right? It's like ML, NNs, CNNs, RNNs, LSTMs, and then LLMs came. It's not like we directly jumped to LLMs and we just used it just because it's going to become crazy or something that time back. But because we understand all the before guys, then we could able to judge with a better knowledge that, oh yeah, LLM is something definitely special than whatever is there before, and this can definitely become 1000x or 10,000x. That was our hinge, saying like, oh, you should start understanding this even better.
Let me pause you there. So in the last video, you would have seen Mohan making products out of AI tech. So AG is the guiding light behind him. He's the guy that we go to because he has got a deep theoretical understanding of how things work. So AG, to make it a little simpler, what we can do is you can take a use case and then explain the AI tech behind it, and probably index more on the tech and less on the use case, so that use case acts as an anchor throughout the discussion.
Right. So Juspay is a payment gateway aggregator, and we connect to almost 300 plus connectors, and we add more every day as we are expanding all over the globe right now. So one thing that it felt like integration can become a factory, and we could able to identify the top level units, say like, oh, there will be a document, use the document, extract the API information, and then generate the types, then generate the transforms, then generate the response handling. And it just felt like, oh, it's very easy, right? The only missing piece in that was ChatGPT or any LLM at that point, right? Why? Because extracting something from document, which is little unstructured, because every PDF will follow their own format, right? Extracting from PDF was not very straightforward. But that's where LLMs really helped us to finish that whole pipeline, right? So yeah, we took CodeGen, so that the project is called CodeGen, and how the product goes is people can upload the document. So we first generate the integration checklist, which validates what all features the gateway contains. Does it matches with everything that Juspay supports, or the gateway supports something extra that Juspay has to make changes in their core flow? And once the integration checklist is proper, we generate a Postman collection. The Postman collection helps us to validate whether the document is correct or not, even before jumping on to implementing, because sometimes, usually what happens is we jump onto something, there will be some small parameter missing in the document, but that would take your days off you. Whereas we could able to generate the Postman and first verify whether the documentation is up to date that we got and all the APIs are working fine. Once we have that, we started generating the flows. And we created a nice UI where people can just click next. But in every step, people can augment, as in they can do prompt engineering, they can make some changes, they can guide the LLM saying like, hey, this gateway is talking about these extra features. Can you also consider these when you're doing integration? So it is not 100% automated, but it's more of 100% augmented by the LLM, and people are able to do integrations much faster compared to the old way.
Got it. What I understand is you want to do gateway integration, and it has to be done faster, reliable, and in an accurate way.
Exactly.
So how many days was it taking earlier, and after this, how fast was it being done?
But if we just talk only about the coding, maybe earlier it was taking 3 days or something, and now it's like less than 1 day.
And can we go a little deeper on what language is used?
Yeah. So in Juspay, we use Haskell. Most of our backend is written in Haskell. So one of the interesting thing when we started CodeGen was the models were okay-ish in Haskell, but not too good in Haskell. It used to make some silly mistakes. So that's when, like, with our deeper understanding of how LLMs are trained, how do they work, right? It helped us to just simply jump on to the next step, which is prompt engineering. First, maybe you can explain in the prompt about Haskell, what is the syntax of the Haskell, so that LLM can make better answer. But the second problem that we faced, other than Haskell being a language, is the context of Juspay. So in Juspay, we have our own DSLs, our own frameworks, and our own helper functions, helper libraries. So if the code generated was not using these frameworks, right, then code is going to diverge, right? So this is the second challenge for us. So this is where we started looking into fine-tuning the model, because what we realized was some of these frameworks don't change much often, right? So what we thought was, if we can somehow make LLM learn about our framework, right, and change the parameters inside the model that knows about our framework, then LLM answers will be much more directed towards our framework than a normal Haskell framework, right? So then we started evaluating fine-tuning as our first step.
So can you tell more about fine-tuning?
So fine-tuning can be seen simply as there is a model that already present, right? And you just want that model to learn about something very specialized, right? As in, let's take, for example, there is a ChatGPT 4 model, right? It doesn't know how Juspay's coding standards are. Like, what frameworks does Juspay use, right? Like, how do we write our code, what frameworks do we use internally and all, right? So what we wanted to do is we wanted LLM to learn about our code and change its parameters. So ideally, after fine-tuning, what you would get is a completely different model.
Yeah, is that what you guys did?
Yes, exactly.
Oh,
Right. And you get a completely different model which knows about Juspay's context, but it's not the original model. You actually change the parameters of the model, and that's what fine-tuning is. And at that time, we were using LoRa because it was one of the advanced one. Even now, it is one of the advanced way of doing fine-tuning, where you can add few layers or modify few layers in the existing neural network of LLM and just tweak those parameters based on your context.
So how is it different from prompt engineering? Prompt engineering also, in a way, you give the context of what you want to do in plain English. So how is this different, better?
Maybe first I'll explain what is prompt engineering, right? So prompt engineering simply talks about add the context, relevant context in the prompt, such that LLM can answer what is the user query. So let's say right now, if I ask LLM what is my name, right? Most probably it can't answer, right? But let's say when I'm asking the question, I also send some extra context, saying like my name starts with A, ends with D. I am from this particular region. I am of this age, and my name is like already used in some of these movies. If I can just give some more context, the LLM can make better prediction about my name rather than not giving any context and just asking what is my name, right? So that's what prompt engineering is all about. Guide the LLM by giving the relevant context in such a way that LLM is able to answer the user query, right? So you have a model X, you asked a question by giving the relevant context. Now model X has answered, and you opened a completely new session and you asked the question again, right? Without the context. Model will simply say, I don't know again, right? Because you didn't give the context and you didn't actually change the model, right? Whereas in fine tuning, you have a model X and you fine tune the model and you get most probably delta X. I'm not calling Y because it's not that big of a difference. It will be a very small difference to X, right? So it's a simply delta X model. And now anytime I ask question, right, it will answer. So because I have tweaked the parameters and I've created a new model, whereas in prompt engineering, I'm just using the current model by just giving the relevant context.
Got it. So now that you mentioned both prompt engineering and fine tuning, is there a rule of thumb when to use what?
Yeah. So the biggest difference, as we talked about, right, is like one is you always send the user context, another one is you change the model. So you choose prompt engineering when your user context is changing every time, right? You use fine tuning when the context is much more static, right? Let's assume what is my age, right? If I try to fine tune the model about what is my age, right, then I have to do it every year because I'm going to change my age every year, right? In that kind of scenario, you prefer to use the user context because it's easier to just change the context the next time I'm asking a question, right? Whereas, let's say something much more concrete, like who invented Pythagoras theorem, right? How does the Pythagorean theorem works? What is theory of relativity? How did Einstein created theory of relativity, right? For these kind of questions, you do fine tuning because it's not going to change.
Right.
Or
for
factual information that's not going to change and you don't want to pass it every time, you do fine tuning. Something that you think will change every time, which is dynamic, which is not constant, right? And based on different questions, you might have to see it in different ways, right? That's when you go with prompt engineering.
So you spoke about giving context, right? This is all about giving context. From that lens, is there any limitation and how do you go about that?
Yeah. So one of the biggest limitation with LLMs, there are others also. One of the biggest is the context length that LLM supports. So context length, you can simply see it as how many tokens it can generate. And here token doesn't mean a space separated word. It can mean different, but you can safely assume that each token is one space separated word, right? And how many tokens does an LLM supports, right, is much smaller, like 2 years back, right? Right now, Gemini or even Meta is saying they're supporting 1 million, 10 million context length. But in the early days, context length was one of the biggest challenge for prompt engineering scenarios.
So this was what 1 or 2 years ago.
Yeah, exactly.
So then, how did you solve for a real world application given the limitations?
Yeah. So even for code gen, there is factual information which we fine tune, but there is also non-factual information that changes every day, right? So it's one of the biggest challenge for us. So at that time, we looked into vector embeddings that given rise to RAG. RAG is a retrieval augmented generation. So in a simple terms, what it means is you choose the context out of a large context. What is only relevant for the user query. So let's say I have 100 documents, right? In prompt engineering, what it says is just send all the 100 documents along with the user question and LLM will answer. But since the context length has become an issue, right? You can say something like, hey, user has asked this question. Can I first find what are all the relevant documents out of those 100 documents which are talking about or which is enough context for an LLM to answer the user query. So that's where it just opened a new way for when context length has become an issue, and that's what RAG is. And we jumped into RAG. Again, the first thing what we did was try to understand how does vector DB work. Even we went back to a little bit of a childhood. What is a vector? How is it represented in mathematics? How is it represented in physics? How is it represented in computers, right? And why vector was chosen? Why not array? Why not something else, right?
Yeah. So in a classic RDBMS, like there is a table which is 2 dimension.
Exactly.
Right. So when you say vector DB, how do you visualize a vector?
Yeah. So vector is visualized in a Cartesian axes. You have X, Y. So let's say if there is a vector of 3 axes, right? You see X, Y, Z.
Yeah.
And you see a point X far from the X axis, Y far from the Y axis, and Z far from the Z axis. And that's what a vector is represented in a visualization format. So the first model which given rise to all of LLMs is a BERT, right? What BERT did was, BERT is actually an embedding model. So what is an embedding model in simple terms is you have an English, right? But machines can only understand zeros and ones. So what is that right way of converting an English word into zeros and ones such that it also carries the context of the word, not just a X to Y transformation, right? So embedding models are always all about that. How can I convert a word into a number or a zeros and ones in such a way that it also carries the information about the word rather than just the number of characters in it, right? And BERT is trained in a very simple way, masking way. We can discuss more later. But BERT gives you an embedding representation. So you can pass a word to a embedding model. You get a representation which contains the meaning also, not just a X to Y transformation. Now, once you have a number or a vector with a representation also, right? It's very easier to compare 2 vectors and say, hey, these 2 vectors are similar. Oh, these 2 vectors are far, right? So let's go back to that example we have taken earlier, right? There are 100 documents and user have asked a question. Now I need to find out in these 100 documents which one are relevant for to solve this problem, right? So what would I do? I take these 100 documents, I send them through embedding model, I get a vector. So I got 100 vectors, and then I take the user query. Again, I send it to the embedding model. I got one more vector. Now, in a space of vector, like if you can visualize, right? In a space of vector, you will see how close this vector with what all in it, right? If you don't want to visualize in vector space also, it's very simple. You can do a simple cosine similarity. So cosine similarity is nothing but a dot product that talks about how close 2 vectors are, right? Once you know they are very close, right? You know they are relevant. So you just extract only those vectors, which are nothing but those documents underlying, and just send it to the LLM, the documents and the actual user query, and you'll get the job done.
See, coming to the dimensions, right? The farthest that I can imagine is 3 dimensions, right? So 4th also I don't know how to imagine. So how do things work inside LLM? How many dimensions are there?
So different embedding models have different number of dimensions. When ChatGPT 4 was released, I think it's around 700 some number, and now I think it's more than 1500, right? So as you add more dimensions, you extract more information about the word. right? But coming back to the visualization part, usually what we do is we do PCA analysis and move it from n dimension to 2 dimension or 3 dimension, because as a human we can't really visualize more than 3 dimension, and there is no way also to even represent something like this, right? So on visualization side there is not much of thing, because it's more of a physical limitation, right? But yes, LLMs doesn't see it in dimensional way. They simply see it, a vector is of n dimension and there is another vector of n dimension. Let me compute a dot product between these two, which is cosine similarity. Just let me see whether they are related or not, right? This visualization usually comes when users want to understand, or users want to see how these two are related, right? So then we do some B-scan, PCA. There are other models, other ways also, which you can use to create a representation, but that is not exactly the n dimension.
Got it. Yeah, lot of theoretical knowledge. So where are we using all of this inside Juspay?
Yeah, there are multiple products we have built, but before even going to the products, right, the one thing that we have done is we have started building a Juspay AI framework. We call it JAF, right? And the major reason for building Juspay AI framework 2 years back is we wanted to simplify some of these abstractions that we understood from first principles.
So any example of a product built on top of the framework?
Yeah, we have. Yeah, before jumping onto the product, one thing I want to say is, it's not like when LLMs came in, suddenly we started building products. Before even LLMs are there, right? Like for 2 years, we have been working on something called code as data. So the major idea of code as data is, can I convert my code into some RDM BMS form such that anybody in Juspay can just query their code, right? That was our major challenge that we are working right before all this is happening, right? And some of the simple examples that we could able to solve was something like, can you find all functions in which I am doing a select query on a particular table called X, right? See, these kind of questions, there is no way for somebody to answer, right? Because you have to go to every function, see the function it's calling, go to the functions it's calling, and find all the DB queries in it and see is it relevant to the table that user is asking about, right? Whereas when we converted the code into a table format, right, and all you can do is simply run a select query, select star from a table where a function contains a function in this DB query on this table, right? So as simple as that, we could able to extract information out of our code, right? And when LLMs came in, we could able to merge these two and build many products around it, right? So we covered the SDLC part, right? Starting with when people are doing coding, what kind of products we can build. And then once a PR is raised, right, what kind of products can we build? And once code goes to production, and let's say there is an issue with the product or there is an issue with the code, right, how faster can we identify it? So we took these 3 challenges and we built products on top of it.
Okay, got it. So let's start with, I think we spoke about code gen already. So what is the next thing? Probably, have you done anything about reviewing the code?
Yeah. So we have built something called Bitbot, right? Again, as I said, right, even before LLMs, we are doing some things. So before Bitbot become an LLM driven guy, we used to have something called CADA, which is code analysis, data analysis, but people likes to call it code as data. So what it does is, when a PR is raised, right, it will split out information about what APIs to be tested, right? And this is purely done from the code as data. Right, so they'll find the nodes that are modified in your abstract syntax tree of your code base. Then they go back and see the handlers or the APIs which has to be tested because this node has been modified, right? And at that time, we also try to find out what dimension should be tested. When we support wide range of payments, and now we are supporting all over the world also, right? And the number of combinations will be so crazy, right? Like card with one-time mandate with EMI enabled, CVV less, direct, redirect, right? See, the combination will get crazy as you go down or go up, right? And finding that exact combination that should be tested when somebody makes a change, right, is a very high value for us. And we went with code as data.
So it's almost like finding the critical path.
Finding the critical path for that change, right?
Right.
And if somebody can confidently say, I have tested this critical path, right? You can directly put that code into the production with your hands up and nothing is going to break, right? See, that's the confidence we want to build using code as data, right? And one challenge that we faced pre-LLMs was, let's assume you have 2 if-else's in your code base, right? Then paths will become 4. Because if with else with if, and else with else, right? You have 10, it will become 2 power 10. You're already at 1 million, right? As you just have like a few more, you'll reach billions, and there is no way you can compute that within a span of a release cycle, right? You'll take a day, you'll take a month or more than a month, right? But by that time, release will be done. So that was the challenging part for us, and that's where the code as data kind of had a stop, hard wall saying like, you have to find a better way, right? And when LLM happened, we could able to relate directly, just like that, we could able to see that LLM is the right direction there, right? So then what we started doing is, we started using LLM to say what branches are important, what branches are repeating, and we could able to reduce from 2 power 10 to 2 power 2. So it's from million, we could able to come to only 4 paths at the end, right? So right now, when a PR is raised, we give 2 informations. One is what API you have to test, and in API, what dimensions you have to test, right? And currently, I can say this is working at a maybe 80% accuracy, because dimensions is still not very solid in Juspay, because we have merchant configurations, reseller configurations, tenant configurations. As I said, right, it's a very big hole. Once you enter the code base, you will find like crazy amount of combinations, right? Identifying important combinations, non-important combinations is still an iterative process, and we are in that process to make it better. So at the end, what Bitbot gives you is, it talks about what API to test, it talks about what dimensions to test, it does a review of your code base following the standards of your project. Then it is very much configurable, and one of the interesting feature that we could able to implement, which is not pretty common in the state of the art reviewer model, reviewer systems, is you can say, see, ours is a kind of a microservice architecture, and we have multiple repos, right? Even inside repos, we have multiple teams playing with different files, right? And I wanted to know when somebody touches the file that I takes care of. So what happens in Bitbot is, I can put a configuration saying like, if somebody changes a change, which is about, let's say, offers, right? I should be the reviewer. Otherwise, you don't have to be dependent on me. But if the change is relevant to offers, without my approval, the PR can't go ahead, right? So these kind of features we are able to implement, and then Bitbot became a very critical now. The review of Bitbot is very important.
The question I wanted to ask was, somewhere you had posted about using this framework to extract intent of the PRs.
Exactly.
Right? Can you talk more about that?
Yeah. So this started when DeepWiki happened. The Devin DeepWiki happened, right? In one of
DeepWiki.
So it's a Devin.
Devin.
Devin is a cognition AI.
Yeah.
It's right. Like, and they did an open source version of Devin, which is called DeepWiki. What it does is, it takes all the open source repos, and it created a wiki page for all the repos with architectural diagrams, with important concepts in the whole code base, and it is very easy for anybody to understand an open source code base now because of DeepWiki, right? In one of the X thread, the one guy mentioned about how underrated commit history is, right? And nobody talks about commit history till that point. Even we went into commit history, but we somehow thought it is too much for us, right? Like at that time. But when somebody at that level has confirmed commit history is underrated, right? Then we jumped in, right? And what we realized was each PR is an intent, right? So let's say people will do a same intent for different features in 10 different PRs, right? So if I can extract those 10 PRs and say, hey, you all have a common intent, right? And using that, if I can create a generic intent, right? So for example, we add new gateways every day, right? And each gateway follows a particular strategy. You have to make change here, and you have to add your code there, right? Now, if you can see 10 PRs following that structure, right? We could able to generalize it and create an SOP out of it, right? Now you have a proper simplified explanation of how to add a gateway with exact points of where to add with 10 references, right? Now you can use this information to guide LLM, like a user context, to do the complete integration without even a human being in the loop, right? And it also helped us to understand our product much better. So now through intents, we know what files changes together. We can able to create the symbol link graphs between the files, symbol link graph between the functions that change together, which help us to know when this function changes, or these all functions also change, right? That kind of gives us a product knowledge of the whole code base, which you usually doesn't get unless you worked on the product, on the code for many years, right? And now anybody, even a fresher who doesn't know anything about the code, can just jump in and know exactly how the whole code is written. And I think it's one of the pretty interesting thing that happened in the space of code in the last 1 year.
This is interesting. So this is more about giving better context to LLMs. How does this compare against what Sachin was mentioning in one of the earlier videos, wherein you create a memory bank and client uses memory bank and it has got more context and then it can take specific commands.
Right. See, memory bank is much more static. I mean, you can update it, but the very first question is when somebody creates a memory bank, right? How are you sure that it's correct? So then you need some senior developer to make sure it's all correct, right? And for a project like Juspay, where I'm saying it's enormous number of lines of code and different combinations, right? It is very, very hard to create something like a memory bank, right? Even if you could able to create using LLMs, right? The very first question that I'll ask is, how are you sure about this memory bank? What is your benchmark? How can I test? How can I say that, hey, benchmark is all, the memory bank is all good and I can able to use it, right? See, I feel memory bank would make much more sense for high level direction about your code base, and it will make even much more sense. Your project is like much smaller, maybe a 10 size, 20 size people or 50 size people team maintaining it, right? But when 500 team people or 300 team people is maintaining a code base, you know how big of a code base it is, right? And for those kind of use cases, memory bank will hit the hard wall. And that's where we also realized. And what we interestingly did was we created a small MCP of our code base, and then we started integrating it to the client, right? Now, when somebody asks a question, client uses this MCP to extract the right context with right functions, right files, with right functional dependency graph, and it knows exactly what context it needs to know to solve the user query. And that kind of made the experience from 80% to 90-95%.
Okay, interesting. So you would still use client and VS Code, but once you connect this MCP, the context becomes even more crisper.
Exactly.
So now I think in the SDLC we covered the coding part, the review part.
Right.
So now the software is deployed.
Right.
Now is there any other tool to augment certain tasks there?
Yeah. So see, usually when something goes to production and it breaks, right, for any reason, the first thing that we wanted to do is identify the box or the reason why this could have happened, right? Because payments is just by simplified payments, but payments itself is like complex because of many things that are the whole ecosystem have too many things, right? Even to identify what is the reason, right? It's a very hard problem, and our ops team does like great job manually doing all these things, right? Then we realized, okay, we can augment some things in Auto RCA. So we build a project called Auto RCA. It's internally called Lightbox, right? And Auto RCA is all about finding the root cause for what happened, what went wrong in the production, right? And how Auto RCA simply works is when we realize something went wrong, right? We look at the logs, we identify the error messages, right? Then we do a checkpointing of our APIs. Then we know in what API actually the issue happened. Then we extract the relevant context, whether it's from configs, priority logic, DB data, everything that is enough to solve the problem, to make a decision of why it went wrong. And what auto RCA's outcome would look like is it tells you the RCA and it also tells you the PR and the exact line and the developer who caused it. It's like interesting, right? Like in a span of like 10-15 minutes, you know exactly the line of change that caused the issue in the production.
Interesting, man. We spoke about a lot of tools. Probably one lens to look at it from is through an SDLC stages. So right from designing the architecture, the MCP augments by understanding the code, and during development of the product, you can query the code base, and during testing and integration, Bitbot helps in review of the code, and even after deployment, if something goes wrong, auto RCA is something that helps quickly identifying which PR led to the issue. So yeah, with this AG, I've been thinking about asking you a philosophical question. For the first time when I connected an MCP to a small piece of code, like, you know, it tried one path, and when that path failed, it went to another path, right? It almost felt like it was thinking, right? So what do you think about it? Was it really thinking?
I think it's too much of a philosophical question, right? So let's break it down how LLMs are actually built in the first place, right? See, LLMs are nothing but next token predictors, right? All they can do is look at the input and predict the next token. And again, the next token goes as an input to predict the next token. Again, it goes as an input to predict the next token till it says, hey, I'm done with the answer, right? So this is the pre-reasoning models way of doing things, right? When the reasoning models came, one of the early one was GPT-03, that was, we all know. They started showing something called thinking, and then they started showing something called answering, right? That kind of made everybody feel like, oh, LLM is thinking and then it's answering, right? Rather than, whereas earlier it used to just split out the output, right? But to see from a technological point of view, even thinking is nothing but a next token prediction, right? So how reasoning models work is they will first start splitting out the tokens about how to solve the problem. And again, as I said, it's a loop, right? Again, as it thinks, it goes as an input. Again, it thinks one more token, goes as an input. Once thinking is done, it uses all of this input to actually predict, actually give you the final output, right? So from a technological point of view, it doesn't feels like thinking. But from philosophical point of view, you can't even answer this question unless you open some consciousness, all this other stuff where you first have to explain what is thinking.
One parallel that I could draw is, right, like, you know, as humans, we feel emotions, right? But when you go to the biological part of it, it is nothing but chemical reaction.
Right.
Exactly. So now when you are sad, you don't say that you are low on serotonin. You're sad. It's an emotion. But don't you think that, like, you know, just next token prediction, when you're saying it is just next token prediction, like, you know, isn't it like, you know, oversimplifying it?
Yeah, from technological point of view, it is. Maybe from philosophical point of view, again, right? Like even maybe humans are also doing the same. Even I might be predicting my next token based on what I've spoken till that point, right?
Just that you don't know. Consciously, you're not doing.
Consciously, I'm not doing. And second thing, I'll give another simple example. Let's say if I ask a question saying why Arvind is a good guy, right? The whole answer will explain why Arvind is a good guy, right? But now let's say I ask him another question, why Arvind is a bad guy, right? It will convince you that Arvind is a bad guy. But if you just draw a parallel to a human, like I can ask you, right, like why Arvind is a good guy, you will say something. But when I ask you why Arvind is a bad guy, you will be like, no man, like he's a good guy. Like I know he's a good guy because I have already answered he's a good guy, right? But LLM doesn't, like.
Okay, it doesn't have a point of view.
It doesn't have a point of view. See, then the consciousness comes into the picture. See, then it goes little unexplanatory, right? Even right now, nobody exactly know how LLMs work. We all know architecture. We all know how things work and all, right? But exactly how LLM makes a decision, it's why LLM makes a decision of what it makes, right? Nobody knows. But I think yesterday only Anthropic released a very a simple tool to show how it works and all, but it is still not to the extent that you actually understand why it's answering what it's answering, right? So now coming back to that reasoning question, right? Yes, it feels thinking because it tells you the steps. So rather than saying thinking, can we call it a plan? it planned, for your question, it planned something, and using that plan, it answered something, right? If the plan is wrong, answer is wrong, right? Whereas thinking might have a aha moments in between, might have some crazy stuff. Yeah, I think drawing a parallel to human right away might not be right at this moment, but yes, it can become that also.
Great. So I think this has been the longest podcast that we have done in our series. It was pleasure having you.
Yeah, thank you so much.
Okay. So as usual, please like, share and subscribe. Most importantly, tag your curious friends who would find this content useful. Thank you.
Thanks.